Look, this is functions. The basic difference between a relation and a function is that in case of relation, the second element can be repeated. Like I'll explain it in detail. I'm giving you some examples of relations, and only some of these relations will be functions. So we need to check that what is the criteria for a relation to be a function. So 1, 2, 1, 3, 4, 5. 1, 2, 2, 3, 7, 1. 3, 2, 4, 2, 5, 1. 2, 3, 2, 4, 1, 5. Now, in all these examples of set of ordered pairs, you can see that here the element 1 is repeated, here also it is repeated. So if there is repetition in the set of first elements, then it is only a relation and not a function. So the necessary condition for a relation to be a function, that there should be no repetition in the set of first elements. So for this reason, this will be only relation. 1, 2, 2, 3, 7, 1. There is no repetition in the first element. So therefore, this will be a function. 3, 2, 4, 2, 5, 1. What about this? 2 is repeated. Will it be a relation or a function or both? It will be a function, that is both, because every function is a relation. Then 2, 3, 2, 4, 1, 5. What about this one? It is only a relation. Is this clear? The difference between a relation and a function?
Yes, sir.
इसको आप लिख दो जल्दी से. Only those relations are known as functions. Only those relations are known as functions, comma, in which the set of first elements are all unique. In which the set of first elements are all unique. Pre-images. No repetitions in the pre-images. Please note it down. All these things people have already done, and there is nothing new in class 10, 12 and 3. वही सारी चीजें. बस अब types of functions है. That's the only thing that is there in our syllabus. What is saying? Done. Now look. Basically, we got just two types of functions. First of all, 1, 1 function. The mathematical condition for 1, 1 function is fx1 is equal to fx2 implies that x1 equal to x2. That is, if their images are equal, their pre-images should also be equal. Then only the function will be 1, 1. For example, A is connected to 1, B is connected to 2, C is connected to 3. No repetitions. So for example, 1 minus 1, and say, for example, this is 2, 3. 1 is connected to 2, minus 1 is connected to 3. So such functions are known as 1, 1 function. That is, there is unique connections. Then only it will be, the function will be 1. Here we need to understand one thing. If not 1, 1, function will be many 1. Now, in what form it can be many one? Like, for example, if a function is like fx is equal to x square, यहाँ पर सिर्फ -1 और 1 है. So -1 का square, that will be 1, 1 का square, that will also be equal to 1. Right? So this function will be many one. Understood the difference between 1, 1 and many one?
Yes, sir.
Second is onto function. Achha, other name for 1, 1 function is injective function. Then we have onto function. Other name for onto function is surjective function. For onto function, necessary condition is the range of the function should be equal to its codomain. इसको हम शॉर्ट में बोल सकते हैं, that is for our understanding we can say no blank image. There should be no blank image, then only the function will be onto if range is equal to codomain. Like ये दोनों ही examples, both the examples, because there is no blank image, so these are examples of onto functions. So 1, -1, 2, 3. This function is also onto function. Now, if a function is not onto, if not onto, function will be into. So, अगर एक भी blank image आ गई, say for example 1, -1, 1, 2, 3. Here 1 is not related, so 1 is blank image. So therefore, this function will not be onto, and hence it will be into. Is it clear? So basically, it is 1, 1 and onto. If not 1, 1, it will be many one. If not onto, it will be into. Is this thing clear?
Yes, sir.
Just a quick recap. If a function is both 1, 1 and onto, then we call it bijective functions. Only bijective functions are invertible. So if we have to show that a function is invertible, we have to show that it is 1, 1 as well as onto. Then these are the few things to remember, that if we do the composite function of a function with its inverse, it will come to be equal to x, where x is the identity function. Similarly, if the composite functions of two functions is equal to x, then these two functions are inverse of each other. And these are the direct results for number of functions from a to b. If NA represents p and b represents q, number of all general functions from a to b is q raised to the power p. This one for 1, 1, this one for onto, and this one for 5. Please note it down.